Now let's look at the next problem. A bag contains 12 balls, out of which X are white. If one ball is drawn at random, what is the probability that it will be a white ball? Then we also need to find if 6 more white balls are put in the bag, the probability of drawing a white ball will be double than that in one. Find X. Now in this case, there are 12 balls, out of which X balls are white. Now chances of drawing the white ball are X. So the probability that the ball drawn is white is X upon 12. Now 6 white balls are added to the bag. So the total number of balls in the bag will be 12 plus 6, that is 18. And the number of white balls would be X plus 6. So the probability that the ball drawn is white is X plus 6 upon 18. Here we are told the probability in the second case would be double that in the first case. So we have X plus 6 upon 18 is equal to 2 times X upon 12. We simplify this. X plus 6 upon 18 equals 2x upon 12, that is x upon 6. Now cross multiply. 6x plus 36 is equal to 18x, that is 12x is equal to 36. So we get x is equal to 3. So we have successfully found out the value of x, which is 3. Now our next problem says, find the probability that a leap year selected at random will contain 53 Sundays. Now we know that in a leap year there are 366 days, that is 52 weeks and 2 extra days. Also in a year there will be 52 Sundays because there are 52 weeks. Now from these 2 extra days, what is the possibility of having a Sunday? Now these 2 extra days could be Saturday, Sunday, or Sunday, Monday, or Monday, Tuesday, or Tuesday, Wednesday, or maybe Wednesday, Thursday, or they could be Thursday, Friday, or Friday, Saturday. Now in how many ways can we get Sunday from here? We could get that from 2 ways out of how many possible ways? Out of 7 possible ways. So the probability of getting the 53rd Sunday in a leap year would be 2 upon 7. Now let's look at our next problem. It is known that a box of 600 electric bulbs contains 12 defective bulbs. One bulb is taken out at random from the box. What is the probability that it is a non-defective bulb? Now here we are given that the total electric bulbs are 600 and there are 12 bulbs which are defective. So the number of non-defective bulbs would be 600 minus 12, that is 588. Now the number of ways in which you can select one bulb would be 600, and the number of ways in which you could select one non-defective bulb would be 588. So the probability of getting a non-defective bulb is 588 upon 600. We can leave this as a fraction, or we could convert it to a decimal form. Let's do it in the decimal form as 0.98. Here you can note the probability will always be from 0 to 1, and it could be written as a fraction or as a decimal. Now let's move on to the next problem. 17 cards numbered 1, 2, 3, 4 up to 17 are put in a box and mixed thoroughly. One person draws a card from the box. Find the probability that the number on the card is odd, a prime number, divisible by 3, divisible by 3 and 2 both. Now in this case, there are total 17 cards. So there are 17 ways to draw a card. Now card drawn is odd when it is one of these cards: 1, 3, 5, 7, 9, 11, 13, 15 or 17. That is 9 odd cards. So an odd card can be selected in 9 ways. So the probability of getting an odd card would be 9 upon 17. Now the card drawn is a prime number if it is one of these cards: 2, 3, 5, 7, 11, 13 or 17. That is 7 prime cards. So a prime card could be selected in 7 ways. So the probability of getting a prime card is 7 upon 17. Now we want a number which is divisible by 3. That could be any one of 3, 6, 9, 12 or 15. That is, there are possible 5 ways. So the probability of getting a number divisible by 3 is 5 upon 17. Now in the fourth part, we want divisible by 3 and 2 both. So numbers divisible by 3 could be 3, 6, 9, 12 and 15. Numbers divisible by 2 would be 2, 4, 6, 8, 10, 12, 14, 16. But the numbers divisible by both 2 and 3 would be 6 and 12. That is 2 ways. So the probability of getting a number which is divisible by 3 and 2 both would be 2 upon 17. Now let's have a look at our next problem. Cards marked with the numbers 2 to 101 are placed in a box and mixed thoroughly. one card is drawn from this box. Find the probability that the number on the card is an even number, a number less than 14, a number which is a perfect square, or a prime number less than 20. The cards in the box are from 2 to 101. Now, how many cards are there in the box? That will be 101 minus 2, that is 99. But both these numbers are inclusive. So we add 1 to it, that is 99 plus 1. So there are 100 cards in the box. Now one card can be selected from these 100 cards in 100 ways. Now out of the 100 cards, how many will be even and how many will be odd? The even cards would be 2, 4, 6, 8, 10 and so on. The 98 and 100. That is, there will be 50 cards which are even. And the odd cards would be 3, 5, 7, 9, 11 and so on up to 99 and then 101. So again there are 50 odd cards. Now the probability of getting an even number would be 50 upon 100, that is 1 upon 2, or we could also write it as 0.5. Now we want the probability of getting a number less than 14. Now there would be 12 numbers which are less than 14, because we will write the numbers as 2, 3, 4 and so on. Less than 14 means maximum 13. So those will be 12 numbers. One number could be selected in 12 ways. So the probability of getting a number less than 14 is 12 upon 100. Simplify this, that is 3 upon 25. We could also write this in the decimal form as 0.12. Now in the third part, we want to find the probability of a number which is a perfect square. Now the numbers which are perfect squares between 2 to 101 are 4, 9, 16, 25, 36, 49, 64, 81 and 100. That is, there are 9 such numbers. So they can be selected in 9 ways. So the probability of getting a perfect square is 9 upon 100, that is 0.09. In the fourth part, we want to find the probability of getting a prime number less than 20. So such prime numbers are 2, 3, 5, 7, 11, 13, 17 and 19. That is, there are 8 such numbers. So probability of getting a prime number is 8 upon 100, which can be written as 0.08. Now let's move on to our next problem. 1,000 tickets of a lottery were sold and there are 5 prizes on these tickets. If Shashank purchased a lottery ticket, what is the probability of winning the prize? The total number of tickets are 1,000 and the total number of prizes are 5. So the probability of Shashank winning the prize is 5 upon 1,000, that is 0.005. Now let's look at the next problem. A child has a block in the shape of a cube with one letter written on each face as shown below. The alphabets written are A, B, C, D, E and A. The cube is thrown once. What is the probability of getting A and getting D? Now on the cube there are 6 faces, so there are possible 6 ways. Now letter A is appearing twice, so the number of ways A can appear is 2. So the probability of getting A would be 2 upon 6, that is 1 upon 3. Now D is written only once on the face, so the probability of getting D on the face would be 1 upon 6. Now let's consider our next problem. A bag contains 5 red balls, 8 white balls, 4 green balls and 7 black balls. If one ball is drawn at random, find the probability that it is black, red, not green. Now in the bag there are 5 red, 8 white, 4 green and 7 black balls. So the total number of balls are 5 plus 8 plus 4 plus 7, that is 24 balls. So one ball can be drawn from these 24 balls in 24 ways. Now we want to find the probability of getting a black ball. Now number of black balls are given as 7. So the probability of getting a black ball would be 7 upon 24. Now we want to find the probability of getting a red ball. Now number of red balls are 5. So the required probability would be 5 upon 24. Now we want to find the probability of getting not green ball. Not green means any other color apart from green. Now there are 4 green balls. So not green would be 24 minus 4, that is 20 balls. So they can be selected in 20 ways. So the probability of getting not a green ball would be 20 upon 24, which is 5 upon 6. Our next problem says 2 unbiased coins are tossed simultaneously. Find the probability of getting 2 heads, at least 1 head, at most 1 head. When 2 unbiased coins are tossed, the results can be heads heads, that is HH, or it could be heads tails, that is HT, or it could be tails heads, that is TH, or it could be tails and tails, that is T and T. So there are 4 possible ways. Now 2 heads can be drawn only in one way. So the probability of getting 2 heads is 1 upon 4. Now at least 1 head. How many ways can we select this? It can be selected as HT, TH or HH. That is, there are 3 ways. So the probability of getting at least one head would be 3 upon 4. We want to find the probability of getting at most one head. At most one head means no head or one head. That could be TT, HT or TH. That is again 3 ways. So the probability of getting at most one head is 3 upon 4. Now let's look at our next problem. There are 40 students in class 10, out of which 25 are girls and 15 are boys. The class teacher has to select one student as a class representative. She writes the name of each student on a separate card, the cards being identical. Then she puts the card in a bag and stirs them thoroughly. She then draws one card from the bag. What is the probability that the name written on the card is the name of a girl, of a boy? Now, total number of students in the class are 40. Number of ways in which a card can be drawn is 40 ways. Now, there are 25 girls in the class. So, the number of ways in which a girl card can be selected is 25. So the probability of getting a girl's name would be 25 upon 40, that is 5 upon 8. Now in the class there are 15 boys, so the number of ways in which a boy's card could be selected is 15 ways. So the probability of getting a boy's name would be 15 upon 40, that is 3 upon 8. Now let's look at this topic from the board point of view. This topic carries 3 to 4 marks in the ICSE board examination. There is one question based on this topic, mostly in section A. Where can you lose marks in this topic? Whenever you are solving a sum on probability, always write down the favorable outcomes and the possible outcomes. Then find the probability. Now note, the probability will always be a number from 0 to 1. If in your answer you are getting negative probability or a number which is greater than 1, then recheck your answer. And you can also leave the probability as a fraction or as a decimal. Now let's take a board problem, which is the March 2009 board question. It says, a dice is thrown once. What is the probability that the number is even, the number is greater than 2? Now for a dice, the possible outcomes are 1, 2, 3, 4, 5, 6. That is, there are 6 possible ways. Now number is even. That means the numbers could be 2, 4 or 6. That is 3 possible ways. So the probability of getting an even number is 3 upon 6, that is 1 upon 2. Now we want a number which is greater than 2. So it could be 3, 4, 5 or 6. That is, there are 4 ways. So the probability of getting a number which is greater than 2 is 4 upon 6. Simplify this to get 2 upon 3. Now let's look at the brain map of this topic. We have now seen what is probability, experiment, equally likely outcomes, sample space, event, empirical probability, and classical probability. Let's revise them at a glance. What is probability? It is the chance that something may happen. Then we had seen experiment. In statistics, when we do a research, it is called experiment. Then we had seen equally likely outcomes. 2 outcomes are called equally likely if they both have an equal chance of occurring. Then we had seen sample space. The set of all possible outcomes is called the sample space. We had also seen what is an event. All the possible outcomes of a sample space are called the event. Then we had seen the empirical probability. The probability based on actual experiment is called the empirical probability. Classical probability, the probability obtained without repeating the experiment is called classical probability. Example, if a coin is tossed, the probability of obtaining a head or a tail is considered equal. Now this topic, actually speaking, is a very vast topic, but in your syllabus it is very limited, and what you have in your syllabus, it is quite simple and very scoring. So you have to get full marks. That is, the probability of you scoring full marks in this topic in your board exam is 1.